All right, let's take a look at 7. I'm going to focus on the brackets first. Let's clean that up before we deal with that 2. So in the brackets, we're just going to distribute that negative through, so it becomes negative 3x plus 4. Close the brackets up, greater than. Let's distribute that 2, so we have 4x plus 6. Let's clean up the inside of the brackets first. So we have 2 times what's going to be 2x plus 4. The other side will drop it down. Then we'll distribute the 2, so we get 4x plus 8 is greater than 4x plus 6. Okay, again, something should be jumping out at you. We have 4x and 4x, okay? Same exact values, same exact sign. So that means that's going to go away. So I'm going to check to see, is this final statement here true or false? 8 is greater than 6, so that is a true statement. Therefore, all of the numbers from infinity to negative infinity are going to be valid solutions. All right, so we ended up with the x's canceling on both sides, and then our statement was true. Okay, number 8. Let's see. So this is a compound inequality. All right, so I'm basically going to isolate the x from the center. Okay, and then anything I need to do to both sides is going to happen on the left with this negative 6 and with the 12. All right, so let's see. So the center is going to be distribution as we would expect, so I'm not going to touch the ends yet. So minus 4 and then less than or equal to 12. So now I'm just going to add 4 in the center, but now I'm going to do it to the left and the right, right? Because this is a compound inequality. I'm really dealing with 2 inequalities at once, right? So negative 6 plus 4 would give us negative 2. Less than, let's drop down 2x in the center. This will go away. And then less than or equal to, what's that, 16? All right, now, in general, to get rid of division by 2, multiplication by 2, we're just going to divide. It's the opposite. So we're going to do it not only in the center, but also the left and the right. So we'll get negative 1 is less than x, less than or equal to 8. And that's our answer, right? So if I was to graph this, here's negative 1, we'll call this 0, here's 8 over here somewhere, open at negative 1, closed at positive 8, and then connect them. All right, so interval notation would be negative 1 in parentheses, 8 in a bracket. All right, so there's number 8. Number 9. So in number 9, we've got a couple of situations happening. Actually, no. So in number 9, this is supposed to be an x. Yeah, I think that's just a typo. All right. Let's see. Let me just make sure. Yeah, that's supposed to be an x there. Okay, or you could turn that into an a, but they're supposed to be of the same variable. That's the idea. So I'm just going to change that to be an x. All right, so let me just add 4 to both sides. We have 5x. That'll cancel, is greater than 20, divided by 5, so x is greater than 4. And then I'm just going to rewrite this. This is supposed to be 3x plus 2 is less than 17. So then we'll subtract 2 on both sides. So 3x is less than 15. Divide both sides by 3. So x is less than 5. Okay, now this is an or, so all of the numbers that satisfy either one is totally fine. All right, so let's take a look at a number line. So we want, let's call this 4, let's call this 5. Any number that's greater than 4 or less than 5. Now, that's kind of a weird question, right? Because no matter what value you pick, it's either going to be greater than 4 or less than 5 at the same time. Okay, so this one is also all real numbers. Okay, there is, no matter what number you pick, it's going to be greater than 4 or it's going to be less than 5. Right, so there is no counterexample here. So there's going to be infinite amount of answers. Okay, and then last but not least, this is another compound inequality. So we're going to isolate the x in the center, so let's get rid of that 1. So we'll end up with negative 22 on the left, less than or equal to negative 5x, less than or equal to 35. And then what we're going to do is divide by negative 5. Now, anytime that you divide by a negative, we have to flip the symbols, okay? So this is going to end up being, so negative 22 over 5 would become positive because you have 2 negatives. Let's flip this over. The x, we're going to flip that again, and then this becomes negative 7. All right? So the interval notation here is going to be negative 7. That's our lower value up to 22 over 5. All right, but we're going to include that because it would be a closed circle as indicated by that little line underneath. All right, so it's just a little line segment from -7 to 22 over 5, open here, closed here, and then connected.